Hi guys, good evening to all of you guys who are transitioning into our year 12 class. This video was made in obviously a very difficult time in the world, and this is just being used as a way to try and support young people who have an interest in physics, interest in science, to try and start to prepare for what A level in physics and even in chemistry will actually look like. So here we go, let's get straight into it. Now, when we first introduce you guys to an atom at GCSE, we talk about the three subatomic particles. So you've got your nucleus, which is going to contain your protons and your neutrons, and we've got orbiting it the electrons. Now, the big thing about this is, this is one of those bits that people really like. I always say to students, remember your pen, your protons, electrons, and neutrons. And we use a phrase here. We talk about the relative mass and the relative charge. Now, unfortunately, in my experience, what happens with a lot of students is they actually ignore these two words, relative, for both. They remember the word mass and they remember charge. And if you ask a student who is fairly good at science or has a basic level knowledge of science, they'll tell you that the mass of a proton is 1, an electron is 0. Sometimes flashy students may say, oh, it's 1/1725 or 50, depending on which textbooks you look at. The mass of a neutron is 1. They'll tell you the charge of a proton is 1, the charge on an electron is 1, and the charge on a neutron is 0. Most people will also remember, again, if we look at the notation of the most common element on Earth, that there are two numbers. And to help students remember, I always say to look at the smaller number. This is because a few years ago I saw an exam question where these two numbers were flipped around. And so we say that the smaller number represents the number of protons. The bigger number represents the number of protons and neutrons added together. It just so happens that in an atom, the number of protons is equal to the number of electrons. Now, this is fairly kind of basic level knowledge, and most people will have this. You guys watching this will probably be familiar with this and find it quite an accessible piece of information. However, let's get into it now. At A level, what we now do is we start to divide up the location of these particles. Now, the first thing we talk about is the nucleons. These are your protons and your neutrons. And we want to try and create a culture of questioning. Why? How? Why not this? Yeah. So let's get right into it. Now, for those of you that can remember, your mass is quite an easy one to remember. The unit of it is kilograms. And yet, here, there is no mention of kilograms. Charge, from your knowledge in physics, is measured in coulombs. And again, no mention of it at all. This is because we're using this phrase relative. Now, the word relative allows us to create numbers that are a lot nicer to use. 1 add 1 is a very nice calculation to be given. However, the true reality is the order or the magnitude, more correctly, of the numbers we're talking about for mass for the subatomic particles is very, very small. Really, really small. And if we start to have a look, it's to this magnitude. Now, most people won't want to add this number together 3 times. It's just not a calculation we want to do. The room for error becomes greater as the number has a very, very small or even a very, very big magnitude. For an electron, if you have a look, it's even smaller, which is why we tend not to use it in the calculation of mass number at GCSE. Now, if you look, interestingly enough, the protons and the neutrons have the same mass, approximately, although once we get deeper into it, there is a slight variation in mass, but it's something beyond the realms of the course that we do. So now if we have a look, we can say that if this is the mass of a proton, why don't we just say that's 1? And because that number and that number are the same, we'll call that 1 as well. And that's where the origin of those two numbers lie. Now, if we now have a look at charge, charge is a slightly different situation because charge is obviously measured in coulombs. Now, if you have a look here, if we consider again our protons, our electrons and our neutrons, the charge on a proton actually is this. And if we compare that to the charge on an electron, we see that the two charges had the same magnitude but a different charge. So what we do is we use the same philosophy we used a minute ago, and we'll go, okay, we're going to call that +1, we'll call that -1. Now, no surprises here. We've given that a value of 0. Okay. Now, when you are doing exam questions on this section, the thing to be mindful of is whether they're talking about the atom or the ion. You may get asked to do a calculation that involves the mass of an atom or the mass of an ion, and you will be expected to factor in protons, electrons, and neutrons. Okay. Any questions at all, please do ask. Otherwise, have a go at working out various common ions and their elements as well.